You know, we really like to think we're at the absolute peak of human knowledge and engineering right now, but what if I told you the ancients had a secret that we completely lost to time? Today we are unraveling a genuine historical and honestly scientific mystery in this explainer. It's one that literally surrounds us, yet it has completely baffled engineers for decades. We are talking about the secret behind ancient Roman seawalls. Why is it that these massive structures, built way before the Middle Ages, actually outlast our highly advanced modern engineering? Well, it's a fascinating story of ancient chemistry, and as you'll see, it's a guide to completely rethinking how we build today.
So this brings up a really fascinating question. Why exactly does modern concrete just crumble to dust, while ancient Roman piers managed to survive for millennia? I mean, picture a modern concrete structure exposed to the ocean. You probably picture something that, after just a couple of decades, is cracked, brittle, and essentially failing, right? The elements wear it down, salt water infiltrates the pores, and bam, it's game over. Yet Roman harbors, breakwaters, and piers, structures built over 2,000 years ago, are thriving in those exact same crashing waves. They aren't just standing despite the sea, they are actually standing because of it.
And it really all boils down to this fundamental philosophical difference. Modern Portland cement is designed to resist water. It's meant to set quickly, become static, and frankly, fight against nature. But ancient Roman concrete, it was intentionally designed to interact with water and evolve slowly. Modern concrete is built to remain totally unchanged, whereas the Roman recipe created a material that continues to adapt long after it hardens. Every single wave, every surge of seawater literally triggers a slow chemical process inside the material that reinforces it from the inside out.
Scientists have been banging their heads against the wall trying to figure this out for a very long time. Marie Jackson, a geologist over at the University of Utah, hit the nail on the head when she said the recipe was completely lost. Her team acted like historical detectives. They poured through ancient Roman texts, desperately trying to find the precise method for mixing this marine mortar. But the written records just didn't hold the full answer. To actually solve this giant puzzle, they realized they had to stop looking at ancient scrolls and start looking through a microscope. They had to look deep into the internal chemistry.
And when they got under that microscope, they finally found the true chemistry of the ancient mix. Roman maritime concrete basically comes from a specific combination of volcanic ash, which is often called Pozzolana, lime, and seawater. When seawater percolates through the concrete, it actually dissolves parts of the volcanic ash, and this allows for the formation of CaSH. That stands for calcium aluminum silicate hydrate. But here is the truly mind-blowing part. These compounds aren't static. As the fluids leach, rare minerals like alto-bremerite start to grow. They form these interlocking platy crystals right in the microscopic gaps within the concrete. They are literally growing new, highly durable minerals that reinforce the structure over time.
Okay, so the structure actually gets stronger the longer it sits in the ocean. But what triggers this self-healing process in the first place? How does the concrete know exactly when and where to start growing these interlocking plates? Well, it turns out there is a secret ingredient. And honestly, it's something that modern engineers originally looked at and completely mistook for a simple flaw.
It all comes down to these little things called lime clasts. These are small, partially reacted chunks of lime that are deliberately embedded within the mortar. For years, scientists looked at these and thought, oh, that's just sloppy mixing by the ancient builders. Actually, scratch that, it wasn't sloppy at all. Researchers now understand that these lime clasts are the absolute secret to the whole self-healing process. They act as dormant repair agents. They just sit there, embedded in the mixture, patiently waiting for a crack to form.
So, let's say you want to bring this ancient insight into the modern day. Maybe you're a DIY builder, or putting together a survival shelter. The reconstructed recipe is highly specific. You are going to need reactive volcanic ash, freshly slaked quicklime, coarse aggregate, and seawater. But the real trick here isn't just what you mix, it's how you mix it. You do not want a perfectly uniform, smooth blend like you get with modern cement. You actually want variation. You want a gritty, uneven mixture with those small pockets of reactive lime clasts embedded all throughout it. You are honestly moving as far away from modern uniformity as you possibly can.
Now, once you've poured your mixture into a mold, you have to follow some highly counterintuitive steps. First off, unlike modern concrete, you must cure this slowly in moist conditions. Second, and this is completely wild, you actually have to induce controlled microcracks. You might use gradual pressure or even thermal shock to do this. Why? Well, because you actually have to simulate structural failure. Without the cracks, the internal reactions remain totally limited.
You absolutely need those microcracks so you can move to step 3, which is allowing seawater to penetrate deep inside, reach those embedded lime clasts, and activate the healing minerals.
And that leads us to this incredibly beautiful paradox. Decay is renewal. Damage actually becomes repair. When the seawater enters those tiny hairline cracks, it dissolves portions of the lime clasts. This creates a highly localized chemical environment where new minerals just begin to form and grow. It's not fast, obviously. It operates over days, weeks, and months, but it is continuous. The dissolved lime reprecipitates as new crystalline structures that physically bridge the gaps. Eventually, the crack is fully healed, and those new crystals, they are often even stronger than the original material surrounding them. No way, right?
So, applying this knowledge turns a quirky ancient insight into a massive modern advantage. While young Roman-style cement might initially lack the immediate load-bearing strength you'd need for, say, a skyscraper, it is absolutely perfect for coastal engineering. Think about tidal lagoons, retaining walls, or off-grid water channels. For survival scenarios or off-grid living, you are creating systems that actually benefit from a harsh environment rather than suffering from it. Plus, you're using locally sourced components, which massively reduces your reliance on our incredibly fragile industrial supply chains.
Which brings us to our final thought for this explainer. If ancient builders created materials that heal themselves through interaction, why do we keep building materials that demand total isolation? The Romans didn't have modern chemistry labs, but they understood materials deeply through observation. They worked with the environment, not against it. It really challenges our modern mindset of building something once, walking away, and demanding it remains completely unchanged forever. I hope this leaves you inspired to think a little differently about failure, about resilience, and maybe even experimenting with materials that are essentially alive. Thanks so much for joining me, and I'll see you next time.